Good morning, everyone. Thanks for coming. It's the third year that we're doing the summit. It was important for us to really create something here locally that we could invite people and start talking about the things that we're doing, the things that we have been doing in the past, and so forth. So I'm not sure if 30 years is middle age. Let's just say it's still young. We still have many years to go. But yeah, so 30 years of MySQL. Obviously, MySQL didn't start with us, right? It started with Monty and with MySQL AB. So it started a long time before us, but we definitely want to recognize that it's a big milestone, and we're doing our best to keep MySQL alive, going, strong, and for a long time to come. So we definitely want to participate in this event. It's not our event, we're well aware of that. It's MySQL as a community's event. I think that's very important to point out, but we're certainly proud of being a huge part of that right now and being part of that 30-year anniversary. So one of the things that we're doing this year is we're having a number of global events. So we start off with this two-day event here right now, today and tomorrow, but then we'll also have a virtual forum, so online forum in July, and then we have a number of regional events coming later this year as well. We just had one in Delhi a few weeks ago, but now we're going to have a few more. The one in Delhi was really well received as well. It was a large audience there, so we have a really great set of customers and developers and users in general across the world, and we really appreciate that. Definitely appreciate everyone here today and a lot of folks that will be watching the content that we're recording online in the next few weeks as we make it available on YouTube. So we still are, hopefully continue to be, the #1 open source database. This is data from last year. And I know there's statistics where it's like, oh, you know, one year it's Java, the other year it's JavaScript, and it's Python. It's the same with open source databases. It's PostgreSQL, it's MySQL, it's something else. But we're always at the top. Whether it's #1 or #2, we're always very high. It's not declining. It's really a solid base. And part of that is because it's a really solid product, right? And I was just asking the team this morning, in terms of bug fixes, for instance, in the last year, because I like to focus between summit and summit, so the last 12 months. And so we fixed 1 bug per day, basically, reported by community users, and then I would say about a similar amount reported by customers and stuff that we find internally. So all of these fixes go obviously directly into the community edition, go into enterprise edition. Things we discover in our cloud service that are part of the server go into community edition. It's all the same code base, right? The core code is the same, it's shared, and we fix things up and down, left and right. And that's really important to us, and everyone benefits from that as well. Anyway, so still #1 database, and we're very proud of that. In terms of industries, I think I showed this slide, similar slide last year as well. MySQL is definitely used across all industries. And one of the things that I found interesting in the earlier days of being involved in MySQL is, you know, it's really easy to install, right? It takes 3 seconds, rpm-i MySQL, hit enter, and it's done, right? You start it up, you do create database. It really just takes seconds to install, get going with it. But it's used by these really big companies in production for huge workloads, whether that's financial industries or manufacturing, where literally a car is built based on MySQL tracking from start to finish, as an example, right? Maintaining inventory, keeping track of the different components during the build process of a vehicle, as a specific example. Or in the finance world, lots of data for financial institutions are using MySQL to provide a service and to do analytics and such internally. So that small engine is used in really, really big environments. And it's pretty impressive, right? Because the most difficult thing, and I remember this on the Linux side as well, running Linux on not a microcontroller, but just slightly larger than a microcontroller, and all the way up to a big server with thousands of cores. It's really difficult to write a piece of software that can scale from the smallest to the largest. And MySQL actually does that really well as well. right? You can install it on a really tiny thing. It runs on Raspberry Pis, no problem, right? But it also runs on big servers. And so as we've done development on HeatWave and got into cloud and now scale it up to a big engine that can do analytics, we can go up to 512 nodes. Technically, we could go higher, but we can now scale a database where MySQL server is the core to something that's like 500 nodes of clusters running one big database, doing OLTP and analytics together. And that's pretty cool, right? It's not easy to do that. It's not easy to do the scale of that because scale is very different between all these things, but we've managed over the years to make that happen. And part of what we're lucky at, part of our advantage, not luck, our advantage is having a cloud environment where we actually host the stuff for our customers, right? Because that gives us the opportunity to understand, and I think I mentioned this last year as well, but it's important to explain this, I think. Part of being a cloud vendor where we host the product is that we learn a lot from an operations point of view. We have to deal with all the installs, and if something fails, we're responsible for it. So we feel that same pain that customers potentially feel if something goes wrong, right? And we do that at scale. We have thousands and thousands and thousands of databases running that we manage, right? And anytime something fails, we have to look at it really quickly because it's a cloud service, right? We need to get that up and running in seconds and minutes, not days. And so we learn from that. We put it back into the product, and everyone else benefits from it as well. And that's a big difference, I think, that we have as a cloud vendor also doing development on a product. And it's the same thing with Linux. I like both Linux and MySQL are in our organization. And so on the Linux side, it's very similar. Every single server that we run in our cloud runs Oracle Linux. Every bug that we run into, we fix for our customers. A competitor can't do that. They don't have that scale of deploying. They don't have that scale of experience. And so I think we bring that. That's a big part of what we can bring from an experience point of view to the products that we provide to our customers. Whether you run it on-prem or you run it in cloud doesn't matter. It's the same code for us. Anyway, it runs everywhere, and that's really, really exciting. I think also one of the things we're doing more of now than that we used to do is having more contact with customers and have more of a direct relationship as to what can we do to make things better, work together on early versions of POCs and such to make it successful for everyone as well. So, year in review. That's kind of the topic of the keynote that I did last year as well. I like to talk about what have we done in the last 12 months. For those that were here last year, what have we done since then? And I think it's important for us to kind of summarize some of these things to see all the cool and new stuff that has happened. So developers are very important, obviously. So we basically have sort of segments. One is, what can we do to make developers more efficient and productive on MySQL, both for on-prem and cloud? Then the second part is performance, HA, failover, and such. And then the third one is management. So how do we deal with making management of MySQL databases better, both on-prem and in cloud? And then, of course, the fourth one is all the stuff we do on the cloud side. So in terms of new features in the last year we announced JavaScript in the database. I think a lot of folks were really excited about that. What we did was we integrated a technology called GraalVM that is built by the Oracle Labs team. And it's a polyglot environment. So it can run JavaScript, Python, Ruby, and a few other languages in one environment. And it's really efficient. It can run this at really high speed. In fact, running Node.js on Graal is faster than just running Node.js as a binary just on your system. But one of the things it also does is it provides a sandbox so that we can create a secure environment of everything that runs within GraalVM. And by creating that sandbox, it allows us to take that and put it into the server and create an environment that doesn't crash the server itself, right? We want something that's embedded in MySQL Server, or Oracle Database uses the same technology, but multilingual support in the Oracle Database. Exact same code, basically, the same GraalVM. And so we integrated that into the server, and it allows you to run JavaScript stored procedures and JavaScript functions in the database. So some of the things that we've added, and these are two really important pieces actually to make it more usable. One is library support. So we provide a set of libraries as part of the image where MySQL runs. And so you can do the import of the libraries that you need for your Node.js, for your JavaScript code to run. And then the other one that we started adding is, of course, if we have all these new features on the server, we want to be able to use JavaScript to access those features as well. So we've enabled Gen AI and AutoML APIs that you can directly call them from within your JavaScript environment. And we'll have a demo on some of this later as well. So we keep enhancing JavaScript. It's very important. The store procedures using the standard store procedure language is a little bit outdated. And so we want to focus on languages that are more popular. With GraalVM, as I mentioned earlier, we can support multiple languages. Right now, we started with JavaScript, but we are looking as a sort of a future statement. We are looking at adding other languages as well in the future. So maybe Python is coming or something similar as well. So we'll see what works the best in this environment. But we will enhance JavaScript, and then we have other stuff coming in the future. Another thing that we've worked a lot on is the MySQL operator for Kubernetes. So Kubernetes is important. The operator was something that a lot of people were asking for, and we've made a number of enhancements to the operator. One is making the operator support backup and point-in-time recovery, so you can integrate that into your cluster. And then the other one is being able to support multiple Kubernetes clusters so that you can set up DR across different environments and basically orchestrate that from the operator directly. MySQL for developer license. So this is something that we did last year. We've done this a long time for the Oracle database, and we've added MySQL to it as well. So basically, MySQL Enterprise Edition is downloadable from oracle.com with a free for development license. So anyone can go to oracle.com, accept the OTN license. I think it's still called OTN, is it? I don't remember. I think it's still called OTN. Just click on the license, and you can download the full Enterprise Server Edition, install it, and use it for testing and development purposes as much as you want. So it's the same model as for the Oracle database. And that includes all the features. So it includes, as you can see, authentication and encryption. It also includes all the JavaScript stuff, MySQL router, everything that you normally have as an enterprise customer, you also get for developers when you download this as well. Always free HeatWave. I don't think this was there last year. We talked about it, but then we launched it a little bit later. So when you go to that QR code or you go to that URL, you can sign up with Oracle Cloud with OCI and get an always free MySQL HeatWave instance. That's the server, so MDS, along with all the HeatWave stuff. So you have Autopilot, you have all the JavaScript stuff, you have all the Gen AI vector store work in there, and as the slide says, we're about to add support for the embedded LLM as well. So there's no need for an extra GPU or an external account. We are embedding Llama inside the service itself, so you can run the LLM and do Gen AI in your free, always free instance. It includes Lakehouse, so you can do some basic processing of data that you upload into our object storage and ingest it directly as well. So everything we talk about here today and tomorrow will basically be possible to use in this always free instance. So I use it personally for my own account, and it's pretty cool. It's really easy to get going, right? And it's pretty powerful. You have a full core. You have 16 gigs of memory that's available and about 50 gigs of storage for data that you can store in your database. We're also talking about REST APIs later, and the REST API service will also be enabled in the free tier. So literally everything that we talk about will be testable on this free service. So if you want to play with it, go ahead. There's a lot of folks that are using this, and it's pretty cool. In terms of deploying anywhere, we're really trying very hard to make sure that MySQL is available both on-prem, obviously, but also in the different clouds. So we have the Oracle Cloud Infrastructure OCI deployment. We're in all the regions that Oracle is, and also all the private regions that customers can install as well. So it's everything everywhere is what we call that project internally. And we have a native service in AWS. So it's a couple of years old now, and we're adding more regions on the AWS side as well. So what we did there is a little bit different than what we're doing with some of the other clouds. You know, with AWS, we actually integrated it in there. It's actually running on their infrastructure. When we look at sorry, Azure and others that are coming, it's running in Oracle Cloud, but there's a direct connect. So slightly different, similar to what we're doing with the Oracle database. But making it available in as many places as a, you know, let's call it the managed service is really important to us. So the MySQL REST service. So this is something that we talked about last year, and it was available through using the Visual Code editor and make it really easy to create REST APIs on top of a MySQL service instance. And so what we've done now is basically integrated into the server itself directly, and as part of the MySQL Cloud Service, so MDS, it'll be a push button to enable it. And it's very similar to what we've done with the Oracle database with ORDS. And ORDS is still available, so ORDS will be able to talk both to Oracle database and MySQL, so that will continue. But this is completely integrated into the service itself. So you don't need to set up a separate middle tier for anything. So you have JavaScript in the database. You have Gen AI and AutoML in the database. You have REST API calls that are directly on the database metadata itself. You can make REST API calls to the Gen AI pieces from this REST service. So all you need is a simple client app, and you have your complete middle tier in the database itself. You don't need to set up a separate VM. You don't need to set up separate containers outside. So for lots of small, medium environments, this makes things a lot simpler. Everything is combined into one place. All the data is local. You don't need to move stuff around. Also more secure that way, because it's all protected with the same accounts, right? And so that was something that we started out doing probably 4 years ago or so as sort of a direction, was what can we do? So the basic idea was, I have a phone app, I just need my database. Everything that you need in the middle, we should provide as part of our database service. That was sort of the basic developer concept that we laid out internally to start working on. And I think with this enabled, we basically got there. Because a lot of the support on JSON in the database, that will help this a lot, and the support for JavaScript makes it really easy to just put it all right in one place. So we're really excited about this, and it's come a long way, and I think we're pretty close to having a full stack solution at this point. So with that, we're going to have a little demo on this because it's a cool feature. So,
hey everyone, I'm Sandeep. Good morning. So Wim just talked about something really, really cool, the MySQL REST service. So why is this so amazing, right? So this is because this REST service has been fully integrated with all the capabilities of MySQL. What that means is that it has been integrated with all enterprise edition capabilities like JavaScript. It has been integrated with all HeatWave capabilities like generative AI, machine learning. It has been integrated with all existing MySQL capabilities like OLTP. So this means that any REST client, your application is just a REST client. It can talk to any on-premise, any cloud, MySQL installation without a mid-tier. This makes it very secure. So what are we seeing here? This is a mobile app, a demo mobile app that we have built to showcase this. So this app is based on a healthcare utility where you have doctors basically monitoring patient notes. So the patient notes, as you can see here, this is for a patient, 3 visits. They are stored in a relational table. in MySQL, available as a live view over the REST service. Now, let's say the doctor wants to generate a summary of all the patient visits, right, for a given patient. How can the application do this? The application just invokes a REST endpoint. Let's say summarize. Because the REST service is inside the database, it can now fetch the notes from the relational table, process it with in-database generative AI, and generate a summary and send it back to the application as a standard REST response. And as you can see here, the summary is now available. This is very, very easy to do. Just a REST request and a REST response coming back. Now, in addition, let's say the doctor wants to send this summary as an email to a third party, maybe an insurance provider. But this summary, as you can see here, has some PII. There is patient phone numbers in there. We cannot share this. What do? We need an anonymized email. We call a custom REST endpoint. This REST endpoint, again, internally, because the REST service is inside the database, we fetch the data from the relational tables, generate the summary, right, using Gen AI. Use in-database JavaScript to remove PII, and then again use generative AI to reformat the summary as an email and send it back as a REST response. And you can see here, the PII has been masked and removed. The email is now ready for sharing. Again, just a REST request and a REST response coming back, making this very secure. Now, let's say the doctor wants to share this email with another doctor, and maybe they don't speak the same language. Again, you want some translation capabilities, right? You call a REST endpoint called translate. Internally, we retrieve the summary, we process it with generative AI, because everything is in the database, everything is in MySQL. And the translated email is now sent back to the application as a standard REST response. And as you can see here, the Spanish email is now available. So all the application is a REST client, and you have the powerful features. You have basically generation, summarization, anonymization, translation, everything available to any REST application. So what did we just see here? We had a REST application that can talk to any MySQL installation, on-premise, on the cloud, wherever you want. Because all of this is exposed as REST, we will be shipping with a set of default endpoints for generative AI and machine learning that you can basically just start building your applications with. If you want to learn more about these endpoints, or if you want to build your own endpoints for more richer functionality, I would heavily encourage you to attend Alfredo's talk in this very room at 1 p.m. today. Thank you.
Pretty cool, right? All within one database service. So I think part of what we're doing is we're taking the things we use internally. You know, our own team uses MySQL HeatWave for translations of documents for the sales team or for marketing, so we're using that internally. We have a demo, I think there's some slides in there later as well, where we use this for support, so we ingest all the internal notes, all the internal bugs and work logs and such, and so then the support team can make use of Gen AI for making it easier to provide support to our customers. And so all that technology is basically put into the service as well, and so we make that available as a chat client for everyone here to use, as well as what we use internally. So we're trying to kind of create an easy-to-use ecosystem. If you don't want to use any of this, you just want to use standard Gen AI, of course, all the standard functionality is available, but we're trying to provide a set of REST endpoints and a set of API calls in the database to really just make it easy to do all of these things. Anyway, there's a lot of content to cover here still, so I'm going to go a little bit fast through some of these slides. I'll just focus on some that are important. The hypergraph optimizer is something that we enable by default in MDS on OCI. It's a much faster optimizer for most of the queries that we do, certainly when it's larger queries, long-running, larger OLTP environments, or also the analytics queries. And one of the advantages we have on the cloud side, of course, is that we have HeatWave running, and there's a lot of statistics and models that HeatWave can contribute to this and make the optimizer a lot more efficient. We included Hypergraph in the community edition as well. It's not the default optimizer on the community side, but you could go and compile Hypergraph in on the community edition as well. And it will have some advantages, right? But I think part of what we can do from an optimization point of view is bring the HeatWave statistics into the engine and make it really more optimal. It's just because we get more data to ingest. Here's an example of that comparing to a few other databases out there. So you can see when you run TPC, both DS and H with Hypergraph enabled, it's a lot faster than prior. In terms of availability, there's two things that we really focus on here, I suppose. One is really fast failover. Right? We really recommend people that use our cloud service to run with HA enabled. We can do failover in like 2 or 3 seconds. So when we're doing updates, it basically reduces the downtime to just a few seconds at this point. It makes it really, really highly available. And we're also doing a lot of work in terms of replication. When you have really heavily used databases, sometimes there's replication lag and the other server can't keep up, and then it keeps the primary then slows down. And so we've done a lot of work, or the engineering team has done a lot of work in terms of figuring out how well replication is performing, and then start doing more management in terms of balancing the workload and making sure that the replicants keep up and the main server is more available. And in most cases, we're doing a lot of work in doing multi-threading, whether that's bulk ingest or that is replication, workloads. We really try to do threading. There's thread pools on the server side for managing larger connection pooling counts or larger connection counts as well. So there's lots of work there. On the HeatWave side, the same thing. You know, with HeatWave, we can look at large clusters, right? I mentioned we can go up to 512 nodes as well. And so same thing here, when there's potential downtime, we want to make sure that the cluster comes back up and running really, really, really quickly. We've added lots of support for dynamic variables, so you can change variables online without having to do reboots. And lots of interesting work happening in this space. Auto-indexing, it's something we also talked about last year briefly, but we made a GA in July, so about, I guess, 9 or 10 months ago. And auto-indexing is an interesting feature, right? So basically, what we do is we recommend, you know, here's 20 indexes that you have today on your table. We think you only need these 2. You don't need the other 18, so you can save a lot of storage space and performance. Or if you create this index, then your performance will go up, and this is how much storage you will use when you create that index. So we've done it in a way that we suggest indexes. We don't just go and create them for you out of the blue and you wake up or suddenly in the middle of the night somebody calls and says, hey, our database is performing differently. It started doing something weird. So we don't do that. So what we do is we get a lot of the data collected, and what we do now is when we see there's a big benefit of creating a different index, we'll actually send you an email and say, hey, you know, we've discovered these patterns on your database. We believe that creating this index will be a lot easier. And we provide you with the create index statement as well. So all the data will be made for you. So you can just basically do cut and paste and it creates it. But it helps a lot with figuring out what you can do performance-wise in a very automated way. Bulk load, so we've done a lot of work on improving ingest a lot, and also the different types of data that can be ingested. And then on the bottom one there as well, we eliminated double write buffers. So basically MySQL Server forever did double writes for anything written to storage. It still does it today unless you have the right storage, but we have added some code on the Linux kernel side that will expose an API call that will say, we trust the storage to be able to do the right block size atomically. MySQL makes that call when it opens the file. And if the call comes back and says, yes, the OS supports atomicity on that block size, then we will do single writes. We fall back from double buffer writes to single writes. So it's not just in the server, it does need a current Linux kernel. It's upstream on the Linux side as well. It's not just in Oracle Linux. It got into the mainline Linux kernel. But we have to ensure that the storage is capable of doing this. And so it's been a long effort on figuring that out. But basically, if the storage supports it, then the Linux kernel will report it, and MySQL will do the right call to the OS to say, OK, this is good. We can trust it. And then we'll do single writes. And that literally doubles the performance, right? On write-heavy applications, you have the number of writes. So it's a big deal. And that is also in Community Edition. It's not just on the cloud side. It's included in the standard code base. Here's some data on bulk loads, but we have some talks on these things. I don't want to spend too much time on it. Warehouse workloads, so JSON support is improving as well a lot. There's a project called JSON Duality on the Oracle database. I'm sure many of you have heard about that. And so we're basically making MySQL be very similar to what we're doing on the Oracle database side. So you get that JSON Duality support in MySQL over time. We're enhancing it basically every day. New features go in. We're enhancing view support to be able to deal with this as well. So MySQL views are getting a lot better than they were in the past. And part of that is to support the road to JSON duality in the MySQL database. This is also in the Community Edition, not just in Enterprise or Cloud. It's important for us to make sure that developers are able to do this on the Community Edition just as well. Anyway, there's a lot of functionality added to supporting larger and larger warehouse workloads. I think we can do, what is it, half a petabyte is the current maximum of data that we support in a warehouse with a HeatWave cluster in OCI. Half a petabyte of in-memory data. So you get really, really, really fast performance. Okay. Query results. So this is something new as well. So when you do a lot of analytics and there's an interesting result that comes back, you can actually write that directly to object storage. So if you want to export that to some other system or you want to keep track of that for later use, we allow you from the database itself to directly export the result data to OCI object storage out of the box as well. So that's something interesting certainly for the larger queries on warehouses. Lots of other features that I don't want to go into too much. Open telemetry support. So open telemetry, OTel is it's a standard for doing tracking of. It's used a lot for application tracking. Like you have a web application, you want to see how long it takes for your client application to make a REST API call, how long it takes for that REST API call to go to the database, and how long the database takes to execute a SQL query that would come back for your result. So you can trace what happens from front all the way to the back. And so that only really works well when the database itself provides that telemetry as well. And so by integrating OTel support in MySQL Server, we can have people do this. We have our own APM support in Oracle Cloud, so we, of course, use our own services for this, but it's based on, it's all standards-based, so if you have your own telemetry collector, then you can use it with whatever other application that supports these standards out of the box. And so it allows you to really start building out a observability environment that goes all the way into the database. So what happens in the database when your application is running? If an end user has a performance issue and it's a SQL query that's slow, you can actually start tracking that all the way into which specific SQL query on which database was doing this. So I think it's important for us as we get more and more really mission-critical environments using this and more people building applications on top of the database. Right? Because part of what OpenTelemetry is used for is really to track that middle tier access. And so by bringing it into the database and by us moving middle tier into the database, we have to expose all of this functionality as well. Monitoring and diagnostics. So one of the things so Oracle Management and Observability and Management Cloud Service in OCI, we've done a lot of work on supporting MySQL as an equal citizen to the Oracle database. So a lot of functionality that we've built into O&M over the years is now also available to MySQL users out there. And we support both on-prem and clouds. If you run a standard MySQL server on a server locally, you can install the agent on that server, and we can manage it the same way in OCI as well as MDS servers in OCI. And strategically, that's kind of where we're going with management for both the databases, right? It's easier to build a management cloud service and make that available that supports both on-prem and cloud. We've been doing that that's been the transition from Oracle Enterprise Manager on-prem, really solid, still very widely used management product and management suite for the Oracle database, and I'll mention later also for MySQL now. And so then you transition to cloud, and we provide a cloud service. It's basically a SaaS platform integrated into OCI for managing databases across the world. Here is that slide. So Enterprise Manager for MySQL. So we have a MySQL plugin in EM. So if you install that, you get all the cool features that EM has been doing for many years for your Oracle database. You get it for MySQL as well. So you have the tracking of best practices that we have for the server. You have all the different standards from a security point of view. We see what's happening on the operating system as well, so you can trace OS plus database. Many of our customers run both Oracle and MySQL, Oracle database and MySQL, so this provides a single pane of glass for both of them. So that makes management a lot easier for the complete real estate. All the Linux servers are managed with the same environment. All the databases are managed with the same environment. We can track Java stuff. We can track WebLogic, other things as well. So it's a pretty comprehensive suite, and provides lots of interesting data. Compliance is probably one of the more interesting things that we have in EM that it's used for. So host security compliance, so all the different standards that people expect to see and have to adhere to in a production environment, we can make use of that as well. So then the last section, and Nipun is doing a session on Gen AI after this, shortly after this, I'd say stay for the real info on this. I'll just kind of go through some of the highlights. But you know, we've provided a complete Gen AI solution directly into the server. And as I mentioned, in the next few weeks, you'll have it in the free tier as well. So going through all of this stuff, where's the slide? Here. So to do this yourself, there's a lot of steps involved. You know, first is creating the vector store and ingesting data into that vector store. So you have all these random documents that you have to go and ingest and push into the database. And then the second part is you have a vector store, you have an LLM, you have to get data out of it and combine the two. And so, you know, yes, you can use ChatGPT and all these other LLMs out there, but the thing is that without data in a database, it's just a point-in-time snapshot of the world's data, right? ChatGPT has no idea what you do in your company, obviously, right? So getting data into a local vector database or vector store is very important to really make use of an LLM in a real scenario for your company, for your applications. Like the demo earlier about patient notes, well, ChatGPT obviously doesn't know about these things. You have to get that data somehow to the LLM. So we make it really easy. You put stuff in object storage, PDF files and CSV files and whatever. You make one API call in the database. It has access to object store and it ingests it all. If you have a large cluster, we do it in parallel, so you can do it really, really quickly. Right? And that's all you have to do. You have tons of data you want to ingest in your database, one API call, and we take care of all these other steps for you. So then you want to use that data. Well, one API call to make a call. What is HeatWave as a question? And off it goes, and it uses the data stored in the vector store from all the stuff you ingested earlier. So if you want to write a really simple application that takes your product for your company, all the documentation that's both external and internal, you upload it to your own object storage environment, you ingest it into HeatWave, and you can start asking questions, use it for internal use, embed it in an application, have a search bar that makes use of this. Literally takes you a few minutes to do this out of the box. So yeah, so there's lots of features in here. One thing that I wanted to also point out is we can make calls to an external LLM, but we embed Llama 3.2 inside HeatWave itself, and we run it on CPU. So it makes it for a, let's call it a much lower cost service, obviously slower on CPU, but the team has done a huge amount of work over the last 2 years or so, certainly the last year, on optimizing LLMs on CPU. And I've heard in the news about other, other LLMs out there doing the same thing, but we've done this as well inside of HeatWave, and it works very well. And so that way we can make it available to areas where there's no GPUs or GPUs would be too costly to try things out. It's a little bit slower, but that's the exact same, it's the exact same code and the exact same effort that makes it work. And by embedding all of this stuff, we are also a lot faster than our competitors. And part of that is because we can do all this parallelization, right? The nice thing with HeatWave is we run many nodes in a cluster, and all these nodes are participating in parallel. We know how to look at the CSV file and chop it up and say, hey, we're going to have different nodes ingest different pieces of that file and in parallel. So we can really optimize the heck out of it, whereas our competitors are typically single-threaded in this space. Here's just 2 examples. One is the example that I mentioned earlier about technical support. So this example is really just saying, okay, let's take all the data we internally have for MySQL that could be useful for support and take the external docs and put them in a HeatWave instance. And then just use that one SQL call that I showed you earlier, and that's what comes out of it. It takes just a few minutes to do this. And it actually works really well. So we've made use of this with our support teams, and we've looked at how much of their job can be made more easily done with doing some of this stuff. And then, sorry, the second part, which you also mentioned earlier, is using the translation functionality and using doc generation. So we have a new release coming out, so we have release notes that we need to write. We have to translate those release notes. But we have all the bugs that are being worked on or have been worked on for that release. We have the work logs in our internal systems and Jira tickets and what have you. And we basically collect all that stuff, and the AI engine basically generates a release notes draft. We then obviously review it with a person or a number of people, and then proofread it, and then we can go through translation, we proofread it, and then we can make use of that to actually release this to the public. Saves us a lot of time both time to do it and time to get it released, right? It solves both problems. And again, all of this stuff is just part of the service. If you sign up for a HeatWave instance today, it's all there. You can do that for your own stuff, just push the button. So it's really easy. And then the last part, and then I'll have the rest of the show go on, more interesting stuff. So in terms of roadmap, we are looking at image support in Gen AI, and that's something that seems to be multimodal support in Gen AI is important. So we're definitely working on stuff like that. JSON duality and just much more improved JSON functionality in the database is really important, right? We know that that's what developers typically depend on nowadays for writing applications, so the database has to do much better support for that, right? So we know that JSON support in MySQL was sort of lagging for a while, but we've really picked up support for developing that into a much better, more competitive environment. And then on the analytics side, it's all about bigger workloads, going to petabytes, and more materialized views is important, of course, as well. So making sure we always get the same same queries done through warehouses. But those are sort of the more interesting features that we're working on. New features in terms of language support, I mentioned earlier that we're working on as well. Obviously, bug fixes that come in, we always deal with, whether it's Community Edition, Enterprise Edition, or Cloud. So there's a lot happening. The team has been very busy, and I think that the pace going forward will be the same as what we've been doing in the last year, the last few years. So it's very exciting. I'm really proud of the team and everyone. Nipun and his team and Mukesh and the PM team, everyone has done a really great job on this, and also the community, right? Getting a lot of the bugs reported, getting feedback from customers and developers out there, it helps us, obviously. And it's one of the reasons we're doing this summit, is to present what we're doing and also get feedback on things we should focus on more, things that should change. And so we do really appreciate the feedback as well. And so we'll start our next 30 years of MySQL development in a month, I guess. It's 25th of June, or May. 25th of May, is that the official date? Something like that. So there's a lot going on. So anyway, have a great summit, have a great next 2 days, and enjoy it. Thank you.